So welcome everyone to the first episode of our podcast series, where we dive into the world of testing automation, quality engineering, and cutting-edge frameworks designed to refine the way we approach software testing. I'm Seth, and today we're going to take a high-level look at what this series is all about. I'm going to introduce you to the revolutionary framework that we've developed and set the stage for what's to come in the future episodes. But first, let me ask you this. How many times have you faced challenges in your testing automation processes? Maybe you're dealing with long triage times, or struggling with maintenance, or just not getting the feedback you need fast enough. You're not alone. In fact, these are some of the most common pain points across the entire industry. Well, that's exactly why we're here. Today, I'll introduce you to a vision for the future of testing automation that can help you solve these very issues. This framework is more than just a tool. It's an entire approach to how we think about and execute testing. It's designed with flexibility, modularity, and data-driven insights at its core. We're talking about a framework that can reduce the total cost of ownership by up to 90%. Yes, you heard that right, 90%. But how is that even possible? That's what we're going to explore throughout this podcast series. Throughout the series, I'll be walking you through the various elements of this groundbreaking framework. The engineering, all the various components and systems integration, the reliability engineering. So from an understanding of vision for quality engineering to how this framework differentiates itself from everything else out there. And more importantly, how it can be implemented in your organization to reduce technical debt and increase testing efficiency. You'll hear about how testers can interact with the system seamlessly, how it supports low-code and no-code environments, and how AI could and should shape the future of testing automation. We'll even break down the business value, how this framework impacts not just the technical teams, but the business as a whole. But before we get ahead of ourselves, let's start at the beginning. In today's episode, I'll give you a high-level introduction to the core vision behind testing automation frameworks. What are they? Why are they important? And what should we be looking for when selecting a framework for your business? So here at Haystacks Tech, we've developed a solution that answers those questions. And in the coming episodes, we'll dive deeper into the technical details. For now, let's focus on the foundation. Haystacks Tech QA vision. At the heart of any successful testing automation framework is the ability to empower testers, not just by giving them tools, but by giving them the right tools that integrate seamlessly into the software development lifecycle. The framework we've developed emphasizes adaptability, meaning it grows and evolves with your projects and your business needs. It's modular, data-driven, and capable of integrating multiple testing tools from Playwright, Puppeteer, Selenium, WebDriver, Appium, and TestCafe to API testing tools with Postman, Newman, Axios, and more. This flexibility is key because software development is always changing, and your testing framework needs to be able to change with it. Whether you're working in Agile, DevOps, or even traditional waterfall methodologies, this framework adapts, helping you manage technical debt and streamline your testing process at any scale, for a small startup or international enterprise with global infrastructure. In fact, one of the framework's most powerful features is its ability to dynamically generate test scripts and correlate performance data with back-end metrics. That means faster feedback loops, quicker identification of issues, and more time for innovation. You'll see a real-world reduction in time spent on maintenance, and most importantly, you'll have a scalable solution that can grow with your organization. Now I know you're probably asking yourself, who is this guy, and why should I trust him? Well, let me tell you a little bit about myself, where I have come from, and some of the things I've done, and why I'm here talking to you now. I've worn a lot of hats over the years, from software testing and quality engineering to 3D graphics and mechanical engineering. But the through line in my career is problem solving through technology and innovation. I actually started off with a Bachelor of Science in Computer Science and a minor in Mathematics back in 2005. Before graduation, I was actually studying 4 different majors: electrical engineering, computer science, mathematics, and physics with a focus on optics. I actually started a business with a business partner back in 2000, right at the end of the dot-com. The problem then was we had no idea what we were doing. We had no vision, no product, no service, no innovation, and no ideas on how or what to start with. We were doomed to fail from the start. I've been heavily involved in software development and systems design ever since. Some of my earliest work included computer-aided drafting, CAD, computer-aided design, 3D modeling, and architectural engineering, where I designed energy-saving housing models and even consulted on marketing and brand imaging for major spirits and vodka companies, doing injection molding, 3D modeling, mechanical engineering, fluid simulations, and component assembly of different kinds of plastic components for advertising and marketing purposes. It was a creative mix of technical and artistic challenges that taught me how to think outside the box. I taught the engineering CAD labs at multiple universities like Walla Walla University in Walla Walla, Washington, Minnesota State University of Mankato, and Andrews University in Berrien Springs, Michigan. I did some consulting for a company that was writing back-end tax audit management systems for the U.S. Department of Revenue and the IRS. I worked with them and wrote the entire back-end sales and use business tax audit management system all by myself in 10 months. It was insane hours and insanely complex. And you can just imagine translating much of the US tax code into actual computer code, and then for building the audit management systems on top of that. Over time, I pivoted more towards software engineering and testing automation. And this journey started at Intergraph, which is now Hexagon. Some things you probably didn't know about Intergraph is that they used to be a leader in semiconductor manufacturing. They were able to pioneer this field of technology because of their work and contributions to the NASA Apollo program back in the 1960s and 1970s. They had this revolutionary new semiconductor design for a personal computer back in the early 90s. While Intergraph was working on packaging and launching this as a product, another company came up with a vaguely similar chip design and released their own personal computer. That company was called Intel, and the chip was called Pentium. Intergraph filed a lawsuit against Intel for theft of intellectual property, and only recently did they win that lawsuit. I say recently, but it was quite some time ago. But of course, it was too late. Intel already won that race a long time ago, as we all know. Intergraph a major role in the evolution of CAD software, particularly in engineering and manufacturing applications. While many associate Intergraph with MicroStation, it was actually Bentley Systems that developed MicroStation, initially as a 2D CAD system running on Intergraph hardware, before evolving into a standalone 3D CAD platform. Intergraph itself focused on industrial and engineering CAD solutions, and its innovations contributed to the advancement of parametric and solid modeling. One of the CAD systems developed at Intergraph was Solid Edge, which was later acquired by Siemens PLM, now Siemens Digital Industry Software. Siemens did not acquire ASYS. That geometric modeling kernel was developed by Spatial Corporation, which was later acquired by Dassault Systems. Instead, Siemens owns Parasolid, a competing geometric modeling kernel that is actually used in SolidWorks, despite SolidWorks being a direct competitor to Siemens Solid Edge. This means that, interestingly, SolidWorks, a Dassault product, relies on a Siemens-owned core technology for its geometric modeling engine. Now, as for me, I personally joined Intergraph in 2008, working in their marine and offshore structural manufacturing department, where I was involved in Smart Marine 3D, now just called Smart 3D, a powerful engine and plant design software used for shipbuilding and offshore platform construction. Later, I also worked with Siemens Solid Edge, giving me a unique perspective on how different CAD technologies and companies have evolved and intersected over time. The Intergraph product I worked on at the time was called Smart Marine 3D, and it was a CAD system for designing tanker ships and offshore drilling rigs. The biggest customer was Samsung Heavy Industries, and at the time they were manufacturing 30 tanker container ships per year in these massive shipyards with factories as big as a medium-sized city. They move around steel plates the size of a soccer pitch like they are nothing. In Smart Marine 3D, they would design the ship as a 3D model. including all the bulkheads, stiffeners, conduits, and outfitting like fire suppression systems, alarm systems, ventilation, hydraulics, electrical, water, cooling. You can imagine how all the systems and subsystems are complex. The hull of the ship must be manufactured starting from flat plates of steel. So our department had these algorithms that would take the hull of the ship and digitally unfold it from the 3D geometry and convert it into smaller segments of flat shapes with edges to cut and match the adjacent plates. However, sometimes the unfolding algorithms would mess up and generate some jagged corners or edges. The engineers could switch to a different unfolding algorithm, but sometimes all of them would fail. Then the engineers would need some way to survive that situation. So I was tasked with writing an editor that will allow the engineers to edit the metadata and the manufacturing data and regenerate that geometry. However, if my editor code broke or failed or was corrupted somehow, then that was the last line of defense. The entire assembly line would grind to a halt. All the robots and engineering and metallurgy staff would be sitting around with nothing to do. This downtime would cost the company about $100,000 per hour. So I learned pretty quickly that my code better be bulletproof. It had better work like an airbag or a pacemaker or aviation software in a military fighter jet or a NASA spacecraft or a nuclear power station. That kind of software where if it fails, someone or perhaps many people would die rather quickly. I learned how to implement quality software the right way. I learned how to follow the code standards and requirements needed, for instance, in medical applications, aviation applications, military applications, and NASA missions. Later on during my time at Intergraph, I was given the task of working with their CI/CD team, and this was before there was such a thing as DevOps or cloud infrastructure. We built our own on-premises DevOps using VMware VM pools on rack-mounted servers running on a WAN, that's a wide area network, that was actually just a corporate intranet, not internet, intranet. Okay, we used VMware and Visual Studio Code along with some internal scripting tools, and it was all held together by a testing system called Mercury Interactive, which was later ported over to HP QTP, also called Quick Test Professional. There was a large farm of PC computers that were hooked up to this corporate intranet, and the servers would push out the nightly build of the CAD software from the 30 or so development teams working around the world. All those binary nightly builds would land on those machines and run through massive libraries of regression tests, generating about 10 gigabytes of test results data every single night. They made it my job to analyze that data every single day and generate non-technical reports to the executive management with responsible names for any errors. I had to look at stack traces and trace that back to specific team or team managers and team roles, and highlight them in the report as a follow-up target. This system was so much work that the only way to keep up and still have enough time to do the rest of my job was to start building an advanced expert system that would leverage a set of heuristics and rules to apply once defects are found by running an automated search against nightly test results. Then reformat the output from those business rules and paste it into an email with non-technical jargon to fill in the gaps. Add in some charts and graphs to meaningfully communicate the outcome of the test results. You get the idea. So after my time at Intergraph, I started building QA testing automation frameworks for companies like Infinity Auto Insurance and Blue Cross Blue Shield. I started incorporating elements of self-writing testing scripts or scripts that could write other scripts. I got involved as a technical reviewer for a book called Advanced UFT 12 for Test Engineers, cookbook by Packet Publishing. There it is right there. I probably can't see it. Then I was hired as a lead QA strategist by IBM. Started working on AI in QA and consulting under their Global Business Services, or GBS division, for many other companies on their QA systems and Scrum processes. I was an Agile coach for SunTrust Bank, and I did QA consulting for mainframe systems at CVS Caremark. I built or consulted on the restructuring of the QA systems architecture and governance and KPI metric models for Bank of Montreal, Ontario, that's BMO, MetLife, and Lowe's. I led or contributed to quality innovations at big organizations like Sam's Club Walmart, SAP Carlots, and Siemens PLM, often building out automation frameworks from the ground up using Selenium, TestCafe, Playwright, and a wide variety of other tools. My focus expanded to continuous integration, CI/CD, DevOps, behavior-driven development, that's BDD, or Gherkin code, and even more advanced methods like combinatorial test design, CTD, also known as all pairs testing. The consistent goal was to lower QA costs, reduce manual labor, and drastically improve the speed and reliability of software releases. I also tackled framework architecture in multiple settings, where that meant integrating unit, API, and end-to-end testing into one cohesive system, or helping teams adopt no-code or low-code solutions so that less technical testers could create automated scripts with ease. As a lead QA strategist, I've managed development teams, set up best practices, established centers of excellence, conducted Scrum meetings, and implemented user acceptance testing, or UAT sessions. When I wasn't building automation frameworks, I was consulting on agile processes, test plan creation, root cause analysis, or artificial intelligence. Use cases in quality engineering or managing and training offshore teams, or conducting interviews, making HR decisions, or appealing HR decisions. Then at one point I interviewed and was accepted for the position of Quality Associate Director at an organization called FINRA. Now, if you don't know what FINRA is, they are the regulatory body with oversight over the U.S. Stock Exchange. That includes the Dow Jones Industrial Average, the New York Stock Exchange, and the various crypto exchanges that operate here in the U.S. I got the offer for $180,000 US a year for that position, and when evaluating my decision, I learned that there would be no room for innovation. So I declined that position and decided to start my own business. My goal would be to bring all this innovation that I have built up over the years for large-scale enterprise businesses and bring all that technology and make it available for the smaller startup companies, as well as the medium and large-scale businesses, of course. But I want my main focus to be on the startup scene, because those are the ones that are struggling the most, and they're the ones most likely to disrupt the larger, more established companies. So my passion for continuous improvement led personally, in my career, led me to found Haystacks Tech, where I'm now the CEO. Our mission is to create a no-code QA automation framework that's open source, modular, and easy to integrate. Because I firmly believe testing should be agile, scalable, and cost-effective. We've done that, and our product is now released through Haystacks Tech. I'm channeling all the lessons learned from big enterprise environments into a solution that helps companies reduce QA overhead by as much as 90%. Beyond my core work in QA and engineering, I've dabbled in spaceflight simulation, Mars direct concept simulations and 3D animations, and even authored or co-authored technical papers, tutorials, and a book. I enjoy tinkering with robotics, embedded systems, and next-gen ideas like alternative energy and reactionless propulsion. Basically, any emerging or impossible, in quotes, I'm doing air quotes here, impossible tech that might just change the world. Not only do I have a passion for impossible, but my passion is to actually build that impossible tech and bring it into real life. Share that impossible tech with others and empower them with the capabilities and value add that it brings. So to summarize my career, I've been writing software for 37 years, starting with my very first line of code on my dad's Amiga computer in 1987 with 256 kilobytes, not megabytes, kilobytes of RAM, and no hard drive. The programming language was Amiga Basic, and everything had to be loaded from floppy disks, including the operating system, which was Amiga Workbench. That was 10 years before Borland C++ came out, and 20 years before .NET was released. I've been working in the testing industry for 25 years. I've been a test lead, project manager, or program manager leading QA teams for about the last 15 years. And I've been working in AI and machine learning and a thought leader in QA for about 10 years. I'm here sharing the wealth of knowledge I've gathered across these diverse roles, from 3D modeling labs to multi-million-dollar enterprise QA teams with global infrastructure, and give you practical strategies for engineering high-quality software. If you're curious about how to make testing faster, cheaper, and more reliable, or if you just love hearing about cutting-edge tech, you're in the right place. Now, I'm sure you're saying, okay, so that's fine, that's you. But what is this Haystacks name? What's with that? So I got you. That's a fair question. So let me break that down for you. At my church, we have this potluck meal where they cover a huge table with big bowls of chips, beans, cheese, lettuce, tomatoes, sour cream, onions, and sometimes guacamole if you're really lucky. Everyone lines up, takes a plate, and piles whatever they want on their plate. It's like a self-serve buffet. At the end, you essentially have a heaping plate full of taco salad, like nachos. Everyone sits down and talks and has a great time enjoying the fellowship and loving, supportive community. Our church calls this Haystacks. I wanted to build the same thing for a tech company, where we have a large buffet of powerful open source technologies you can self-serve, surrounded by loving, caring, and supportive community of fellow companies and hackers, right? That's what we all want. So that is Haystacks Tech. So as we wrap up this first episode, here's what you can look forward to in the next few episodes. We'll dive deep into how this framework redefines quality engineering, which sets it apart from existing solutions, and how it provides tangible business value in today's market. And I'm excited to take this journey with you. And I hope you're ready to discover a new vision for testing automation. Thanks for tuning in. Make sure to subscribe, and I'll see you in the next episode, where we'll dive into the vision for quality engineering and what it means for your organization. Also, all of the content we cover in these podcasts is available in our white papers. There'll be a link in the description, as well as a link to our webinar of our custom development platform and scripting language. I love you guys. God bless. I'll see you soon. Take care. Bye-bye.